Hey everyone, thanks for joining this first ever live stream that I'm doing. This entire thing started off with this project called CombineExt, that's part of Combine community, and a couple members of the community wanted to know how to build some specific operator, and I thought it would be a good opportunity to just share it with the entire community and show everyone how it can be done. So that's basically it. I'm not gonna go through some of the combined basics. Just gonna like talk about some of the basic terms, but not gonna. I'm gonna assume you know some combine already. So first of all, combine is basically a framework that lets you subscribe to things and then get values from these things as they happen. That means that you can subscribe to a network request or even some Bluetooth status and get updates constantly so you can keep your app up to date. So this thing you subscribe to is called a publisher. I'm going to switch to my iPad and show you how that looks like. So basically, if you have this entity called a publisher, it has two generic constraints, which is the type of values it can emit, for example, integers, and some error type. That can be anything that's a Swift error. So it can be my error, for example. And on the other side, we have something called a subscriber. And you can think of that as basically a consumer, anything that can accept these values. For example, when you use something like sync or sign, these are basically subscribers. Okay, so this publisher doesn't know, it doesn't publish values immediately. It only publishes once it's attached to a subscriber and that specific subscriber asks for these values. So this entire process starts off with the subscriber being attached to the publisher via the .subscribe method, and the publisher will get that specific subscriber in its receive subscriber method. At that point, the publisher creates something called a subscription. So that subscription basically signals the specific connection between that one subscriber and the publisher. So at that point, the subscription and subscriber talk to each other. The publisher still exists, but these two talk to each other, and the publisher is a bit out of the point at this point. And then starts something a bit weird that's called back pressure. I'm not going to go too deep into it, but basically it is what I said, that this publisher with the subscription, it can't publish events on its own. It can't just do it without the subscriber telling it, give me some values. And only when it says that, it would give it some values, for example, 1, 2, 3. And once it gets these values, it can increase its demand, saying, I want more values, etc., etc. So this is just the basic stuff. Again, I said I'm not going to go too deep into this, but it's just to get acquainted with the terminology. So the thing we are going to talk about today is operators. So I want to define what that is. So if you have a publisher that, for example, has values 1, 2, and 3, we can use an operator, which is basically a method to basically manipulate any events coming from that publisher. So if I put it through something called map, which is the same map basically that you know from Foundation, right? And I would say $0 plus 1, I would get 2, 3, 4. Map. And that would be the affected publisher basically. Daniel asked a very good question about cancelables. Basically, when there's a subscription, that subscription can be canceled using its cancel method or upon the allocation. That's a very specific detail about how Combine works in general, how the memory management works in general, but it's interesting and good to know because that's basically the reason why you have a subscription. So you have a way to cancel the specific connection between the publisher and one subscriber. Cool. So that is the basics of what is an operator. There's also one term I want to define here, and that's something you hear a lot when talking about Combine, but also about other reactive framework, and that's called upstream and downstream. What does that basically mean? It basically means that if you have something like this publisher here, that is the upstream, meaning it publishes events downwards. And this is the downstream, this is the consumer. So this would be the entity that actually accepts these values eventually. So we have a top to bottom kind of flow of data. So that's just two basic things. We're going to use them in the code as well. So it's important to remember upstream and downstream, but you're going to see a lot of code that relates to that as well. Before we jump into the code, I just want to say that there are two ways to create your own operators, and I'm going to show you both of them. The first one is basically composing and reusing existing operators. That's the easiest way, right? Because you're just leveraging what Apple has already built for us. The second option is building custom operators. That one is a bit trickier because you need to handle this back pressure that I told you about earlier. You need to handle the fact that your operator can't publish the modified values unless the subscriber asks it to. So that's a bit trickier, but I'm going to show you examples of how to do both. Robin asks, how do cancellables differ from dispose bags in RX? So RX, or specifically RX Swift, has something called a dispose bag, where it would contain a bunch of disposables, which are like cancellables, basically. And you can dispose of that. That entire bag will clean its disposables when it's deallocated. But disposables specifically don't get canceled when they're deallocated, which is very interesting because in Combine, as soon as some specific subscription is deinitted, all of the work is canceled as well. So that's a very big difference between the two. But you could compare a dispose bag to a set or array of n-cancellables, basically. Cool, so we have the basics behind us. We're gonna jump into some code. Cool. So this is actually the CombineExt project I told you about earlier. It has some operators here that are custom operators, some that I built, some by members of the community like JustDev, who is in this chat as well. Thank you for all your contributions to the work here. So I want to show you some of the basic approaches to basically composing your own operators. So I'm going to make a new file called basicoperators.swift. Make sure I'm on the right target. And there we go. So I'm going to import Combine. So the first thing we can do, again, is reuse other operators. That's basically quite easy. For example, we can make an extension for every publisher where the output is Boolean. And that basically means this extension would apply to publishers that emit Boolean values. And I can make a toggle method, or as we call it, an operator. And inside we can call map. And we can just do not 0. And that would return a map of self to Boolean. And we can actually return that same type here. Publishers map self bool. We can even make it more succinct by basically doing this. So now we have our custom toggle operator that just leverages the map that we get for free from Apple. So that's very useful because we can make specific contextual operators that reuse more higher level operators that we get. So I want to show you, I'm going to write a quick test just to make sure it works basically, even though we know it works, but a test is always good to have. So I have this tests thing here with a subscription, basically just the cancelable that we talked about earlier. I'm going to make sure I nullify the subscription after every test. So I get a fresh one. I'm going to do test toggle. I'm going to make a source publisher that has false, true, true, false, .publisher. I'm going to make another array that would contain my values. And I'm going to store in the subscription source.toggle that we should now have. It probably just, let's build it. Here we go. And we're going to use sync to get all the values out of this and append them to my values array. And I'm going to just do xct assert equal. Values would be the opposite. So true, false, false, true. I'm going to run this. Awesome. That was a very quick way to show you that basically you can leverage existing operators to make your own ones. This one is very, very simple, but let's do one even a bit more difficult, a bit more interesting. So we're going to make something that works for every kind of publisher. And we're going to call it pair. And it's going to emit pairs of numbers, or pairs of elements. So basically, if I have a publisher that goes 1, 2, 3, 4, 5, we would expect to see 1, 2, 3, 2, 3, 3, 4, and eventually 4, 5. So we are going to connect a couple of operators together. We're going to actually do some operator composition here to get to that final result. So let's start writing. I usually don't put the return type just so I can write peacefully and then satisfy the compiler and its complaints. So I'm just going to put this here basically. So the first thing I'm going to use is something called scan. And scan basically lets us manage a state. For every element that's published from the upstream, I'm going to get the previous state and my current element so I can modify that state. So if I start with an empty array, I could get that array every time and the current value. And I could add my new element. I can return a new buffer with that element if I would want to. Okay? But what we actually want to do is get only 2 values because we want pairs, and they would always be the last values. So what we do is basically take this, take the last 2 elements using suffix. This would be an array slice, and we want to go back to array. So I'm going to convert this back. So now we would get the first time 1 element, then 2 elements, then 1 element, then 2 elements. So we only want the 2 element case. So we can filter where we have 2 elements in that specific array. And that is basically the entire operator. We would buffer the values every time we would add the last value and then get a window of only the last 2 values. And then we're only going to publish the cases where we have 2 values in that specific array. Now, one interesting thing about operators, as we said, they are themselves publishers. So the return type here is basically filter of a scan of self to self output. Many times, in this case, like in toggle, it's kind of nice because you are mapping from self to Boolean, and that's quite helpful. But in many cases, you don't want to reveal the implementation details. The consumer doesn't really care that you used other operators to do this. So we can use something called erase to any publisher. And then we can return an any publisher of the output and failure type. In this case, it would be an array of output and whatever failure type was part of that publisher. Now we're going to make a test for that as well, very quickly. Test pairs. So the source would be 1 through 5, a publisher of 5 numbers basically. We would store arrays of integers because, again, we want the pairs. And we'll do the same trick as before. Source.pair.sync and append into our values. And now what we expect to see in values is an array that has 1, 2, then 2, 3, then 3, 4, and eventually 4, 5. If we run the tests, we see that everything works as expected. I'm going to remove an element just to show you that it works as you would expect. Cool. So that was just to show you that you don't have to go through the custom route every time you want to make your own publisher. you can start by leveraging existing publishers and move on from there. But many times that would be quite hard to do. There are operators that entirely change how your publishers work. And I'm going to show you how to make those custom ones. That's basically the main purpose of this live stream, because those are quite tricky to get right. A little sip here. I'm just gonna look at the questions. Mechanical keyboard clicking. Yeah, I love my my DOS keyboard. Sorry, my DOS Ultimate keyboard. It's just a coincidence that sequence.publisher property asynchronously bits out the expectation, so we don't need an expectation. So in that case, we don't have anything that delays the values, so we can test them this way. Many other times you would want to have an XT expectation, but not in this specific case. All right. Okay. So I'm gonna make a simpler operator and then move to something more fancy. I do want to show you one more thing in the drawing section. So we said we have a publisher, and we have a subscriber, and we have some subscription. So the thing is that when we make our own operator, we need a way to manage what the demand is here, so we can only give this whatever it expects, not all the values that this necessarily publishes. So inside CombineExt, there are two tools built in to do this. I'll show you in a moment, but basically what that tool would be is something called a sink. And that's not any official term. It's something used commonly in reactive frameworks. But you can think of a sink as basically just another subscriber. So we put another subscriber in the middle here, and it would consume all of the elements from the publisher and buffer them in some way. And then only when this one expects them, meaning the downstream, that specific buffering subscriber, the sink, would publish them to the downstream subscriber. Cool. So back to our code. Hey Bob, hi from Berlin. Good seeing you here. Objective Dave, what are your thoughts on using any publisher as the return type versus some publisher? I think that basically both should work. I don't have any specific thoughts about that. I personally don't use some publisher, but I know some people who work this way. I think it would work the same for most cases. Okay, cool. So I want to show you first the sync that I talked about. I'm not going to go into the implementation details of this because there's a bit of code here, but I do want to show you that what it gets is the upstream that we talked about, meaning some publisher. And we see that upstream is the publisher, and downstream would be a subscriber, meaning some consumer expecting the values. And every time we would receive a value or a subscription or a completion event, we wouldn't pass it to the downstream subscriber, we'd pass it to the sink instead. And the sink would use some internal buffer. We have something called a demand buffer specifically to buffer these values and events and only pass them forward once we get specific demand to it. So to do this, as I said, the sink is itself a subscriber, and it immediately subscribes to the upstream to start getting all of the events. And then it buffers them, and whenever comes the time where there is specific demands, we pass the demand to the buffer, and the buffer knows to flush its buffer to the downstream. So that's basically also why we call it a sink, because we have upstream, downstream, a lot of water metaphors, and sink is like a water sink basically, where all of your values funnel to. Cool. So I'm gonna make another file called repeat output. So this operator is gonna take every value that comes from the upstream and emit it some specified number of times. This could also be achieved by composition, but it's just a very simple example to show you of a custom operator, so we're gonna go ahead and do that. I'm gonna import combine. So the first thing we do is create a publisher. And it's always nice to put it in the publisher's namespace, in the scope of publishers, because that's what official Combine operators do as well. I'm going to make a repeat output class that's a publisher, and I'm going to let the compiler guide me, basically. So it's looking for some stubs. It wants to know what's the output and the failure types. So to know that, I need to know what I'm repeating, right? So what I'm repeating would be the upstream publisher. So we would have some generic constraint here of the upstream. And the output would be upstream.output and upstream.failure, because we're basically just relaying the same output type and the same failure type, just repeated. What else are we missing? As I mentioned before, when you have a new subscriber, you get it in this method as a publisher, and you are responsible for creating a new subscription and pass it off. So I'm just going to clean up this automatically generated code here. Subscriber. We don't need this, and we don't need this. Cool. Now we basically satisfy the compiler. We need to create a subscription that we can do subscriber.receive subscription. So to do that, let's create our own subscription now. So what's nice is that both the subscription and the sync or whatever you use downwards can be entirely private. So private extension. I'm going to put an extension on the repeat output publisher itself. Different people might do like private extension, repeat output subscription. I kind of like to scope it because then you get the same output and failure constraints from the top object, but that's a matter of preference. So I'm going to make a subscription, and it's going to be a combine.subscription. I have to write combine to disambiguate my own subscription and combines the thing I'm conforming to. So what does it want me to do? Let's see. There is a request method that I would get a specific demand, and I need to fulfill it. And also there's a cancellation. So here it would be, if I'm getting a demand, what do I do with that demand? And here it would be, when I'm canceled, what do I do with that cancellation if I want to do any cleanup for my work? So do I need to do anything else here? No, I'm already conforming here. And I'm not going to pass the subscription yet because we are still missing some things. So the last thing we want to take the upstream, the publisher that makes the one value, for example, and the downstream, and take the one value and push, for example, 3 values downstream. Okay, so we already know that this subscription is going to need both of them. So we already have upstream defined here, so we don't need to define it again, but we're going to define downstream subscriber. And we're going to do where upstream output equal downstream input and upstream failure equal downstream failure. So really you must have these types match, right? Because you can't pass an integer to a string subscriber, obviously, unless you have some way to convert the 2 pieces of data. Cool. And I'm gonna create a sync in a bit, but I don't have a sync yet, so we need to make that now. Cool. Let's get to our sync. Cool. Class sync would inherit from CombineExt sync. So let's look at our sync and see it needs the upstream and the downstream. So it would need the same specialization as well. So we're going to do downstream subscriber. And we're basically going to copy this generic constraints. And yeah, we need to specialize with specifically the upstream and downstream, the generic ones that we get. Cool. Now we get by default an initializer like this. The initializer would get the upstream, the downstream, and two basically functions that let you transform the output to the of the publisher to the downstream, and that's really helpful when you have different types. This isn't the case we have here, and also we would want to have some custom implementation. So we would get to this in just a moment. One thing I forgot to do here, by the way, is that if we have, if you want to repeat, then we want to get a number of repetitions. So let's actually add an initializers that takes number of repetitions and stores it here. Great. And the sync is gonna probably take the same. So it would need the upstream, the downstream, and the number of repetitions. So it needs all these different pieces. Here we're gonna create our sync, which we don't have yet. So let's finalize that one. So again, we need to pass down the upstream. And we are basically gonna leverage the existing functionality of the sync that we have in CombineExt. I'm gonna do the downstream, and we're gonna take the repetitions down here as well. We're gonna store the repetitions because we need them here as well. And do self repetitions, and then we're gonna call the super to get this initializer that I just showed you. I'm gonna pass the upstream, the downstream, and I'm gonna just pass the identity function here because we know there's no transformation that we actually need to do. Cool. Yes. Here we go. Let's just build. Okay, so now there's a final thing in this sync that we want to do here. So the sync, as you see, when it gets an input, it would just pass it down to the buffer. The buffer would also return a new demand, etc. But that's, again, implementation details. So we would want to override that because for every value we get, we want to buffer 3 repetitions or 2 repetitions or whatever. So we're going to actually override no autocompletion. That's fun. Let's see. I'm going to just copy paste the signature. Cool. And I'm going to go from 1 to number of repetitions. And not only do I need to loop over all of them, but I also need the accumulated demand that's returned from all of the buffering event. So I'm going to reduce into an empty demand, basically. I'm going to get the current demand and the repetition index, which I don't need. And here, I can return the current demand plus the demand that's resulted from buffering the current value. So what's happening here is that I'm going to buffer one value, the amount of repetitions that I get here. And also I'm going to return the accumulated updated demand to the output here. I also don't need this return here. This is actually our entire sync. So now we have all of our things in place. Let's fill up the subscription, pass it here, and we should have a working publisher. So let's define a sync here. Private var sync. Sync is specialized with one thing, a downstream. So we're going to pass our downstream type here. And we're going to make it optional because on cancellation, we want to nullify it so it stops buffering, stops doing its work, basically. All right, so now I'm going to create the sync. I'm going to pass upstream, downstream, and repetitions. Awesome. And I'm going to pass the demand to the sync. It has a method called demand, and we just pass it the demand. Now we have everything plugged, basically. We have a sync that takes values from the upstream, and for every value, it would basically push down as many repetitions as you want. Whenever we get demand, we push it to the sync as well, and then the sync manages everything for us, basically. Now we only need to pass the subscription here. So we're going to do subscriber.receive subscription, pass down upstream, which is our publisher, Downstream, which is actually the subscriber, right? Our new consumer that's going to accept these values. So we're going to pass subscriber. And the number of repetitions we got in the initializer. Whoop. Here we go. Upstream. Oh, I need to store the I need to actually accept the upstream as well in my publisher. Because, right, that makes sense. So let's accept that one. I'm going to store it as well here. Upstream. And push it here, basically. Upstream. I'm going to do this. Here we go. Nice. Everything's compiling. I'm going to write some tests now to validate that it works as we expect. I'm going to look at the chat here first. Let's see. Is there a runtime cost of creating any publisher? I don't think so. It's basically just type erasure. We don't. It's just a way for us to erase all of the data of the operators. I don't know of any performance cost, but if you hear of anything, let me know. Does subscribing on init possibly kick off side effects for code publishers? That's interesting. Basically, no, because it depends. Again, we are buffering the values and the events coming in. If you're saying side effects, for example, handle events, which is like do on next on RxSwift, then the value wouldn't come in until we have demand, right? So the side effects are only going to be a resolution of the demand of the subscriber anyways. Cool. Prince Ugua, I'm sorry if I'm mispronouncing your name. Why do you choose to have the publisher a class versus a struct? I asked because I remember in the video they describe publishers as structs. I think it depends on if you want them, by reference or are copies. I don't think it matters much in this specific case, but that's a very good question. If I figure out there's a fundamental difference, I will definitely write it in the comments later on. And Joanne Deschaux asking, since you are covering some foundation concept, would have been better if you would have gone without the custom implementation of sync and demand buffer. There's no real way to do that, basically. It's not really a foundation concept, right? Creating your own custom publisher that handles demand properly is an advanced concept, and I'm just showing you how you can do that. You still need something to manage the demand and buffer the events and the values. And you can basically copy it. It's MIT license, so you can take the buffer and sync as is and use it in your own code if you want to. I'm going to go to my tests. I'm going to use the same test file for now because it's not a huge deal. And we'll add another test. Test repeats. And I'm going to use strings this time. A, B, C dot publisher. And again, I'm going to accumulate these values in this array so I can assert against them in a moment. So I'm going to store the source dot repeat. Oh, I don't have the actual method, right? So now we have publishers dot repeat output, and we can actually create it this way by passing the upstream and everything related to that. But what we really want is a method that we can actually leverage. So we're going to add an extension on every publisher. It's called repeat output and takes the repetitions. It would return a repeat, a publishers dot repeat output of self, because we need to pass the upstream as the generic upstream, the constraint here. And we're basically only going to return publishers dot repeat output. Upstream is self and repetitions is repetitions. All right, cool. Now we can actually test this. Subscription equals source dot repeat output 3. So it's going to take every, we expect to see AAA, BBB, CCC. Sync values append 0. And now I can do XCT assert equal values AA, B, BB, and C. Let's run our tests here. Awesome. Cool. So now we have our very basic custom publisher that uses the buffer and the sync that comes with CombineExt. I see that Mark and Johan asked that they mean specifically about combine without using the extensions. Yeah, I understand the question, but again, you need to have some way to manage that demand and buffer the values to push them downwards. There's nothing built into Combine that we can use to do this. So we have to build something custom to manage the demand, basically. This is basically about how to leverage it to create a new publisher, but not how to build that entire buffer from scratch. That's an entirely different session that I'm happy to do as well if anyone's interested in the implementation details of that. Cool. Now we're going to switch to the last operator. So the last operator is what actually spurred the idea for this live stream. So myself and Louise and also JustDev talked about some operator called AMB. And for people not coming from RX Swift, I want to show you what that operator is. So AMB, also called race in some languages, in some implementations, for example, in RxJS. Whoops. I don't have the nicest handwriting, I'm sorry about that. So what it would do is basically take two publishers and only pass down the events of the first one to have some event. For example, if this completes and this still didn't do anything, or this started emitting some values and this didn't, then if I have one here and this didn't do anything, then we would get P2 coming out of here and this would be canceled. That's basically what this operator does. So it's actually very useful for a lot of things, but in many times where you have, for example, timeouts or things you want to race between them, so you only get one publisher out of it. So this is a very, this is a much trickier publisher because it doesn't accept one publisher, it accepts two publishers, and it needs to manage both of them and decide, make an actual stateful decision on which of them wins the race. So without further ado, I think let's just go into the code and start writing that one. Cool. We're gonna basically do the same thing. We're gonna make a new file here. Nice for AMB. Here you go. You all happy now? Okay, cool. I'm gonna make a file called amb.swift. Import combine. And we already know a couple of things. We know that we're gonna accept two publishers, not just one. So let's make our AMB class publisher. And we have output and failure again. So we're just gonna actually get two publishers constrained here. And the only concern that we have is that both of them has to have the same output and failure types, because both of them need to be equal, right? If I have something that emits numbers and something that emits strings, then we can't have a single consumer taking both of them. So we're gonna do where first output equals second output and first failure equals second failure. And I'm gonna store them both in the publisher. Make a public initializer that passes them both and store them. Self-sconed. Okay, now let's fill up all the stuff we need to conform to the protocol. The output could be either of them because they're equal. I'm just going to use first. And we're going to need the receive subscriber method as well here. I'm going to clean it up in the same way. Here we go. Yeah, sorry for the loud typing that goes on here. That's the biggest upside of a mechanical keyboard, right? That you can type very, very loudly. Sound like you're a war machine. Cool. So now we have a publisher. It doesn't do anything. Let's create a subscription and a sync and everything that we need in between. So like before, excuse me, we would start with a private extension on AMB and create a subscription. And we already know that we would need to get some subscriber to push the values to. So I'm going to already define that. And it will conform to a combined subscription. And we would want, again, the output and the input to match. So I'm going to write that as well here. Output, downstream input, and failure equal downstream failure. Great. And I'm going to already accept all the data that I need, which is going to be the two publishers and the downstream. And we're gonna need to have the two demand and cancel methods as well. We'll push those downwards. Perfecto. And now an interesting part here, we actually want to handle the demand on both, right? So we need one sync per publisher. We're actually going to make two different syncs. They're going to be the same sync, but two instances of the same sync. So let's actually switch to let's actually make the sync now, because that's the next thing we want to have. Here also we would need a custom sync because we want to know what we need to do is actually know when each of the publishers do something. Something means it either emitted a value or a finishing event, either completion or failure. So we're going to create a sync that's going to let us know when it does some work. And then we can decide which of them wins the race in this case. So let's do the same here. What is this missing? Nothing. Okay, cool. Private extension on publishers.amb. I'm going to make a sync that's going to have the upstream and downstream constraints like before. And CombineExt.sync upstream, downstream. And again, I'm going to have to constrain the output and the input to match. Cool. Whoops. There we go. So what do we need? We need the upstream, the downstream, and we need a way to notify whoever is holding the sync that this specific publisher did something, right? So the way I chose to do this, which I think is just simple enough to get the job done, is just pass a closure. So I can have an upstream, a downstream, and something called emitted, or whatever you want to call it. It would just be a void-to-void closure. And I'm going to need to, of course, it's an escaping closure because it's outside the scope of the initializer. We're going to store it here. And again, like before, we're going to initialize using the super initializer to the parent sync. So we're going to do upstream, downstream, and identity. Nice. So now we know we need to do a couple of things. Basically, we want to retain the same behavior of the buffering, but we want to call this emitted closure right before. So let's take the receive override. We're gonna return buffer.buffer input, and we're gonna do the same for the receive completion. And the only thing we're going to change here is that we're going to call emitted from both of them. And that is our entire sink. So it basically just gets the upstream and the downstream and this closure. And then whenever this sink receives a value or any event, it would call this closure, and then we can know in the subscription that specific, that either first or second, who came first, basically. So now we need to build the subscription itself. I'm already going to make some enum just to clean things up called decision. It's going to be either first or second. That's pretty self-explanatory. And of course, we're starting off with nothing. So in the subscription here, I'm going to start with a decision, which is optional and nil. Cool, and we know that we're going to need a sink for each of these publishers, so we're going to define both of them. First thing, sink between first and the downstream, and a sink between the second and the downstream. And we know that on cancel, we want to cancel all of our sinks. It doesn't matter which of them, so we're going to do first sink nil and second sink nil. Great. So now we get first, second, and downstream. We need to actually create our first sink and second sink. So let's do that. First sink would be a sink that accepts upstream first, downstream downstream, and emitted closure, which we're not going to do anything in yet. We're going to do that in a moment. And the second one will do the same for the second upstream. Second, downstream, and emitted. Cool. Now, what do we actually want to do here? Basically, we just want to set the decision to either first or second, as long as a decision wasn't made already. So we're going to just make sure that decision is different than nil. And if it is, then we're going to set it to either first here or second here. So we're going to wikify self on both of them and do garp self equals self and self decision equals nil. Else we're not going to do anything. So if we do have a decision from the second one, for example, we're just going to return and not do anything because the decision was already made on who won the race. But if not, we're going to say self-decision equal first. And we're going to do exactly the same thing for the second one, but it's going to be second. This is a really good question by Just Dev. He asks, do we need any locking on decision? So on ArcSwift, we have a recursive lock on this specific situation. I assumed that yes, but I ran a lot of tests and it didn't have any issues. I'm going to run some more tests and make sure before I publish this operator to CombineExt. My instinct says yes, but my test said no, so I'll run some more tests and let all of you know. Cool. So now what do we need to do? We have a decision and we need to do something with the decision. So we can actually just do a quick did set on the decision here and decide what we do with it in either case. So decision equal decision, else return, switch on the decision and say if it's the first, we would nullify the second sink, and if it's the second, we would nullify the first sink. So basically, if the decision is that the first publisher is active now, we cancel the subscription to the second one, and if the second one is active, we cancel the subscription to the first one. Excuse me. And now we need to request the demand to get the ball rolling. But there's one more thing we didn't deal with, which is quite important. First of all, if we accept any demand while we don't have a decision, we don't want to do anything with that demand. We want to store it and push it later because we don't know which of these publishers is going to use that demand. So what we're going to do is actually store the accumulated demand before the decision making. So you're going to have a private var pre-decision demand, and it's going to start off as none. And on the request, which is basically whenever we get demand from some downstream subscriber, I'm going to make sure that if I don't have a decision yet, I'm going to accumulate the demand that I got and return immediately. So I'm not going to pass the demand to either of the sinks until I know which of them is active right now. But then when it is active, we can basically call both of them here. We can do demand, and for the second as well. And the reason is that one of them is going to be nil at this point. Whenever the decision is made, we're going to nullify the other one. So it's going to be, one of them is going to be nil here, and only the other one is going to get the demand. And now what we actually need to do is calculate the demand together with the pre-decision demand, which is only going to happen for the first time, basically. So we're going to say needed demand equal the demand that we got here plus the one we accumulated, and we also are gonna make it none if it wasn't. That means if I have some demand already stored, I'm gonna put it in my needed demand and ask both of these for the needed demand, and I'm gonna make it none. So we only want to fulfill it for the first time when we make a decision. So now when we have this, Daniela has a really good question that I'm going to answer in a moment. Okay, so now when we have either decision, after we nullify either of the sinks, we can call our own request, meaning this one, with the pre-decision demand. And that should basically be most of the operator or all of the operator in its very basic form. We are going to still need to create a subscription here and pass it down. So let's do that real quickly. Okay, so we're going to do subscriber receive subscription, and you're going to pass first, second, and subscriber as the downstream. That should be it. Now Daniel asks a really good question. Why would a sink emit anything if it hasn't received demand request though? That's entirely correct. We have a contract that Apple has that basically says if you don't get demand, you don't publish things. But every operator that Apple has, as well as every operator that we want to make custom, you would want to protect against illegal publishers. Because those can happen, and those do happen basically. So you do want to buffer the event, make sure you protect your own operator, your own publisher, whatever you make, for the situations where that could happen. Now, the last thing we would make is an amb operator function that would use our method basically. So we're gonna make amb, and we have one publisher here and we need a second here. So we're gonna make a generic constraint called other, and we're gonna pass a secondary publisher here. And this is gonna return an amb on either self or other. And again, we're gonna constrain the output of other with the output of this publisher and the failure as well. And all we're going to do, like with the repeat publisher, we're just going to call publishers.amb, pass first and second. And first would be self, and second would be other. And that's it, we're compiling. Let's make a quick test. I have an empty file here called amp tests. I'm going to do the same teardown thing here. Test amb values. I'm going to make two subjects, so it will be easy to test. And I'm also going to store the completion for later on. So I can test that we get a completion from one of them, and we're going to store the values that we get from the M publisher. So subscription equals, we're going to do subject 1 amb with subject 2. And we're going to store the completion event and append values. And now what we're going to do is basically just send values to them. So we started with subject 2, so we know that should be selected. Let's just push a bunch of values here. 6, and let's do 8 here. So because 2 is the first publisher that we push a value to, we expect this, this, and this. And we expect none of these to actually be pushed down. So we are going to do xct assert equal values 1, 2, 8. And I'm already going to tell you that this test is going to fail, and that's expected. I'm going to show you why in a moment. It succeeded for some unbeknown reason. There is one thing that you should know, that when the subject emits the values, I'm just going to make sure because something feels weird here. Okay, it does succeed, but I probably added that mechanism somewhere else in the code. The issue is that subject 1 and 2 are pushing values down, but yeah, now it actually failed. Yeah, that's a failure we were expecting. I'm not sure why it didn't fail on the first time. So we're not getting anything. And the reason is that we have two subjects that we send values to, but none of them, the subscriber, which is our sync, doesn't have any demand towards these subjects. So they're both not publishing because they're respecting the demand of the operator itself. So the operator needs to go to both of these and basically ask them, demand them for a single value. So we're going to go back to our subscription in AMP Swift, back to our sync actually. And when we receive the subscription, we're also going to want to ask a single value, a single event from it. So we're going to relay the super call to subscription, and we're going to say to the subscription request a maximum of 1. So this is us asking both of these basically, right? Both first and second, give me one of your events so I can know which of you came first. And once I do that, our test should work. I think there's just a caching thing here going on. Here we go. So now the operator works as we expect, but let's add a couple more just to make sure that we are on the right path. So we expect a couple more cases. For example, if we have an amb of empty and never, and that means something that completes immediately and something that never emits anything, we expect the complete immediately to win, right? So let's have the two subjects that we're testing as well. We're going to make an empty publisher that completes immediately false, and a second one complete immediately true. So basically, complete immediately false mean that it would never end. It's a never, basically. And complete immediately true means it completes immediately, so it's like an empty publisher that immediately brings back a completion value. We're going to store the values here as well, but we don't have any values, right? We're basically going to do a trick here. I'm going to start the completion event as well. We don't have any error here. So the way for us to know which of them fired is basically to make each of them push some value after they complete. So we can do something like append, and then we can distinguish which of them basically completed first. So we would do subscription, our first AMB with the second, and we would use the same sync that we did before, completion equal 0, and values append is 0. Excuse me. So now, because this one completes immediately and this one never completes, we expect to only get this one, and we don't expect to get anything from the second one. And we also expect the entire thing to complete because we have a publisher that finished. And we only have one publisher that finished. So let's do XSD assert equal. Values, we expect to have only one. Let's run this real quickly. I hope that Xcode's cache won't betray me again. That looks good. And the second thing we want to test is that we actually get a completion of finished. Why is this important? Because if we got the second one, the first one, we would never get a finishing event. We would only get a finishing event if the second one was chosen, which is what we actually expect. So this should pass as well. Awesome. We can do the same for basically empty and never and never. And it's pretty easy to test. Basically, if you have empty and empty, you would expect basically the first one to finish, and it wouldn't matter because they're both empty, so they both would complete immediately. It wouldn't matter which of them wins the race. And for never and never, you would just expect to have no values, no completion events. They're going to be frozen. So this is basically how you would create your own operator. I just want to complete here the test for this with a completion event like we did down here. So we know that we won't get a completion event yet because none of our sources have completed. Both the subjects are still active and we can send values to them. I'm going to send a finishing event. Whoops. Xcode autocomplete strikes again. So now we expect this to still not be complete. Why? Because we know that we are using the second subject because AMB would pick that one. So even if the first one completes, we shouldn't get a completion event. So we expect this to still be nil. Let's run this to confirm. Awesome. Now I'm going to send the completion event to the second one, and now we expect let's do equal completion to be finished, because now the source that we're actually redirected to would be the active one that actually finished the AMB operation. So those are some basic tests. Joanna asks, does it make sense for AMP to have a variadic parameter? Absolutely. That is actually the last thing I want to show you before we wrap up. We're going to go back to AMB. And like we have other, we're going to have one more that takes an other publisher. And it would get a bunch of others using this splat variadic operand. And because we don't know what is going to be the specific type of each of them, we're going to have to erase them using any publisher like we talked about earlier. So we already know we're going to get back an output in failure of this publisher because we're going to do AMB with this publisher and all of these publishers. So the trick here is that we are going to AMB starting with a never publisher like we did earlier. So it means we're going to start with a seed of an empty publisher with the same output in failure. And it's going to do completely immediately false. So that's a never. It's never going to do anything. So we know that AMB would never pick it. So it's a really good seed for our reduction in this case. So we're going to reduce over all of the other publishers. Turn others, reduce. Oops, I need others here. reduce, and we're going to start with never. Actually, I just realized you don't want to do that. You want to start with self, because self is the first publisher you're going to ambiguate from. So I'm going to have to basically erase every publisher I'm working with, so I get an erased publisher on the output. So now I'm going to get my final result, which is going to be one erased publisher and the current one. And I'm just going to do amb on all of them. So I'm going to take my previous result and do amb with my current one. And again, I'm going to have to erase that second one. If not, the compiler is likely to complain. Oh, it doesn't. Awesome. Cool. So now we expect this to be an any publisher of self output self failure. And that is all that's basically needed. We're starting off with the seed of myself, the self publisher, and we're going to do self plus the first, amb with the second, amb with the third, amb with the fourth, until all of them are sort of ambed together. And then whichever of a gazillion publishers wins, all of the others are going to be unsubscribed from, and only one publisher is going to be pushed through. So this is the entire implementation of this custom operator, and this is a relatively complex operator. It's not too many lines. We have 140 lines here, including the methods that wrap the actual publisher. And you can see, looking at the code here, that other complex ones like materialize are also not too long. Same for dematerialize or with latest from, which is like a very known operator from ArcSwift that we don't have in Combine yet, unfortunately. This one is also 160 lines. I don't think you need to erase that. Other is constantly the same for all others. Let's see if you're right, then that would be nice. But it's actually, I'm not actually sure that's true, because nothing guarantees that other would be the same as publisher, right? Publisher could be my publisher int never, and other could be other publisher int never. They're not the same type, so I don't think you can amb them together and return a single thing without erasing them. But that's a good question. I don't mind trying that just to let's do this. Whoops. So it says cannot convert value of type any publisher self output to closure result type self. Yeah, basically it doesn't know what I want from it, because it doesn't know how to connect these two pieces together. It doesn't know if they're actually the same type or not. So it's important to, I want to just focus on this thing one more time, that the fact that we have two publishers that have the same output and failure doesn't mean they are of the same concrete type. This is actually part of the reason we have to erase all of them. Awesome. I think that this is it. If there are any questions, I am open to hearing them now. And if not, then forever hold your silence. No, I'm kidding. But this is a good opportunity to shamelessly plug that if you want to support my work and you want to learn more about Combine, this is the book that I wrote with Scott Gardner and Florent Pillet and Marin Todorov. Awesome people. This is a really great book to get started on Combine. It doesn't have all of this stuff in it, because this is more of a getting started with practical Combine using the tools that Apple gave us. And what I'm showing you here is really custom stuff that most consumers don't need, and but some people do need, because it is very interesting. And I think that a lot of developers are interested in how to create their own publishers in this case. Feel free to go to the CombineExt project. It's on github.com/combinecommunity/CombineExt. And if you have any other questions, you can reach out to me on all of the social networks. Perfect. And that's it. Thanks so much. These are all my social networks. Feel free to reach out to me. I'm happy to answer any and all questions. And also, one final thing, please contribute your own operators to our project. It's open, and you can ask all the other people in this chat, those of you that are active, that we are super open and super want to help and teach how to add custom content to the library. Um, yeah, as Mark said, thanks, Shai. Consider this my vote for watching you again, maybe showing the innards of the custom sync and demand buffer. Absolutely. I actually would love to do that. I think I'll do a live stream on something a bit more basic next time, and then we're going to do another deep dive into how you can manage demand and back pressure. Cool. Thank you all so much. See you next time. Thanks for tuning in. And no guitar playing, but I can show off my guitar if anyone is interested. Perfect. And my tiny guitar as well. Anyways, thank you. Have a go. I just realized I showed you something in the camera and it's not active. Oh well. Okay. See you next time. Thank you for joining, and feel free to reach out. Bye-bye.